On the bench today we have a Yaesu FT-757GX II. Boy, what a mouthful. Customer sent this one in to get some work done to it. Note he sent along says the radio has very weak AM and FM receiver is extremely quiet and S meter shows near 0. SSB and CW have more gain, but uncertain if they're optimal. Even with the preamp on, there is no hash or noise, but when someone in close proximity transmit, it seems to blast through and break up. Was told by a local it could be an 8-volt 100 milliamp lamp fuse bulb. Give her what she needs. Also, please check the temp sensor contact with the final if questionable. Yeah, it's the heatsink compound that they use on there. Sometimes that temp sensor loses contact with the final transistor, and you get some erratic fan operation. It also says, also please set up to about 120 plus watts on AM carrier. It makes the drive control adjustment much smoother. Meter acted a bit strange when I transmitted too. Well, I can tell you right now, I ain't doing that. If it's a watt above 100, I'm going to turn it down. You do not turn the power up on radios like this. If you want to throw this radio in the trash can, have at it. Screwdriver away at it. So yeah, I'm just ignore that bottom paragraph. That's not happening. So I've got it hooked up to the communications test set, and what am I feeding into this at the moment? Minus 110 dBm. Okay, so that should be, if it's got any receive, we should be able to hear something at minus 110 dBm. Have it set to 28 megahertz. Where in the hell is it there? I turn the volume up. Can't say I really hear anything. If I turn on the RF amp, because remember he did say even with the preamp on, there is no hash or noise. Now I can hear the sound, the audio. Just barely, it's there. So we'll leave the volume at halfway, turn the preamp on. It's receiving. If I hit the attenuator, we'll just check to see, make sure that's not maybe stuck on. Nope. Turn the attenuator on, it disappears. Now, here's the interesting thing. This has a notch and shift control. The notch has an off position, so it's a clicky rotary switch. You can click it to the off position, which it is right now. Listen what happens to the receive when I turn the notch on. You can see the signal strength meter. Oop, just bumped the control. Turn the notch filter off, and the receive doesn't completely disappear, but yeah, that's would kind of seem to act in almost kind of backwards, don't you think? The notch filter really shouldn't affect the overall receive sensitivity of the radio. The notch filter, as the name implies, what that does is that actually applies a notch. So if you look at your signal and your noise and everything that's coming into the receiver, there is just that. There's a notch. It's a filter. It's a fairly tight bandwidth or very narrow filter. And as you turn the control, you're shifting that notch back and forth, and it blanks that section out. So if you have an interfering noise, or like if you're on sideband and there's somebody leaking in with maybe an AM carrier, you can shift that notch over basically to, well, it's not really squelching, but you can blank out that interfering noise with that notch filter by moving it to wherever the noise is. But yeah, that seems kind of strange. You turn the notch filter on and receive increases. So maybe we have a problem with the notch filter switching circuit, possibly. I don't know. Another thing was, this guy said, note the fast button on the face is used for toggling the 11 meter full coverage mod. I don't see that. I'm not sure what the heck he's talking about. Well, I mean, I see the button fast, but notice, okay, half rotation got me, what, about 40. Okay, yeah, roughly 40. So you start at the bottom, and if I switch it to fast, it gets me to, you know, almost 400. So it's almost 10 times faster turning speed. That's what the fast is supposed to do. I don't see where that's affecting the lockout, the Mars cap mod whatsoever. Matter of fact, if we go down to CB, I don't know, I really honestly don't know what he's talking about here. We'll put it on 27205. If we change over the test set, let's see, we'll just go ahead and put the frequency there as well. And we'll set the analyzer. And if I hit the MOX button on the top left corner of the unit, that'll place the radio and transmit. And there's our carrier. Matter of fact, it's putting out, look at that, 50 dBm. Perfect. 50 dBm is 100 watts. So yeah, I'm not going to actually touch the power at all. But now, if I push the fast button and I hit the MOX button, it's still transmitting. Maybe the AGC fast? Maybe that's what he meant. Let me push that button out. Nope, still transmitting. I have no idea. I quite honestly don't know what he's talking about. That button, or even the AGC speed, the fast slow button, yeah, it's not affecting the Mars cap mod, so who knows. But it does have the receive, and honestly it's not that, it's low, don't get me wrong, the receive is low, but it's not like it, he makes it sound here where the receive is extremely quiet. The S meter shows near 0. Like I say, it's got receive with the preamp on. You could hear it switching in and out the preamp. It's just the notch filter. Man, that really seems to have an effect on it. So let me get the covers popped off of this, pull the schematic out in the block diagram, take a look at it, and see what might be hiding inside this critter. Okay, well, at least I had the camera on so you could see the problem happening before. So the only thing I've done is take the covers off and just inspected some of the wiring and whatnot here. And actually the customer had sent with the note here an invoice where it had been previously worked on. And I'm not exactly transistor, yeah, it looks like actually that's on the bottom side. There was a transistor replaced, had a battery, the memory battery was probably installed, trimmer resistor, trimmer capacitor, I'm not sure, it doesn't say, not very specific here, and a bright white LED. So any case, I got the covers off here, pulled out the service manual and took a look at it, and this radio has come in a couple different versions. This is the GX2, so this control is the notch and the shift. The previous version had, I think it was width and shift. Didn't have the adjustable notch filter here. It had a shift, or not shift, had a width control here. And you remember when you turn, in this radio, the problem we were having, when you turn the notch filter on, the receive came back. It seemed like it had good receive. Turned the notch filter off, AM just kind of went away. It was still there, it was just noticeably lower. So the way that circuit works is it's basically more or less bypassing this ceramic filter here. So these, of course, these radios have lots of filters depending what mode you're in, AM, sideband, FM, CW. So there are, just on this board you can see there's 1, 2, 3 crystal filters, and then there's 2 ceramic filters. So you have the ceramic filter here, and where is, let me mute that other radio over there, that wasn't this one. And there's the other one right there. The signal comes in this direction, cross through a couple FETs here, all these tuned circuits along here. This is your receiver chain, and comes through, and this transformer couples basically in and then the output. but depending if you have that switch turned on and off, it's whether this filter is basically in or out. So with the switch turned off, the only thing I did was that. That's it. That's all I did to it. Okay, there's off, there's on. That's what I would expect. Actually, the received sound will usually drop a little bit when you turn the notch filter on. And actually, I'm now feeding in minus 115 dBm, so an even lower signal. Oop, I just bumped the tuning control. So I'm going to say it still seems a tiny bit low, but like I say, we're receiving there at minus 115 dBm. Could be a bad solder joint, but honestly, I think what's probably wrong with it, the ceramic filter. If you own any vintage amateur radios, if you have a bunch of amateur radios, you're probably familiar with the plague of ceramic filters. Yeah, I don't know what it is. Some of them seem to last forever. Other ones, I'm not going to say they're unreliable. I mean, you got to look at how old this radio is to start with. But yeah, for some reason, some of them don't last, some of them do. And actually, the newer ones used in some amateur radios seem to be worse than ones used in radios like this. I've seen some radios less than 10 years old now where ceramic filters are going bad. Dino sent me a picture of one that he worked on for somebody in his ham club a few months ago. They troubleshot through it, and had either, I can't remember, it's either no or extremely low receive, and traced it to a ceramic filter. He actually cut it open, and it was just green inside, and it's not supposed to be green. It was all corroded. So yeah, I don't know what it is, man. The manufacture of these things doesn't seem like rocket science. CB radios have ceramic filters, and they seem to last forever. I think I've changed maybe 2 ceramic filters in CB radios. And actually, the kicker there is, this is the same filter bandwidth that would be used in a CB radio. It's just the brand that they use, the brand, specific one that they used in some radios. But yeah, and that's actually the reason I tapped on it, and that's something you can try. I have found over time replacing bad ceramic filters. Now, if it's green and grungy inside, it's just oxidized and corroded, yeah, probably tapping on it's not going to do much. But in my experience, I have found bad ceramic filters by doing just that, just tapping on it. If the receive comes in and out when you're doing that, a lot of times that's what it is. It's the ceramic filter, and all it is in there is little chunks of ceramic, some plates, chunk of ceramic, plate. And I think they just start to lose contact. I'm not a filter manufacturer, so but yeah, it's almost like they start to lose contact, maybe tension on them. They're not making really good tension. But yeah, if you do that and the receive comes in and out, or if you don't have any and you just tap it like I did once and boink, the receive comes back, that's probably a filter. So yeah, now the painful process. I have to pull this whole board. I think the easiest way is, of course, take all the screws out, disconnect the coax cables on the back side. I think you can fold this one up fairly easily. Folding it this way is a bit of a nightmare because that's where most of the wires are routed from. Most of the connections on this board come in this direction. So you can see we've got a coax here, one here, and that's another thing. Whoever had this apart last didn't put it back together properly. That's just how I found that coax cable when I took the cover off. Smashed. It's starting to recover its shape, but you can see it's kind of smashed flat there. Yeah, they had this coax routed over top of this heatsink, and it was smashed in between the cover and that heatsink. So yeah, I need to make sure when I put this back together that I have this over out of the way so it's not getting smushed by that heatsink. So let me get some screws out here, get a couple cables and a couple connectors. Like I say, it's a lot easier to fold it this way, and get this thing extracted out of here. And like I say, I'm not going to change it until I know for sure it's not a bad solder connection, because that's very possible too. But yeah, I'll check to see if the solder connections look good in that area. Yeah, it's the filter. I'll just stick a new one in. So I'll be back. Actually, what I'll do is once I get this thing released, I'll fire the camera back up. Okay, so I've got the RF unit pulled up now. Like I say, it's not too bad to pull out. You'll never get this board because you have to. All of these stick out the back of the radio. So in addition to the screws, there's 5 screws, one in each corner and one roughly in the middle of the board that screw it down to the platform here. You'll also need to pull your forward set knob off the back, the little plastic knob right there. But you'll also need to remove this nut off of the jack. So just take your de-stuffing tool, and yes, people always ask me, Mike, where do you get these things? China. They're cheap. It's called and don't ask me who in China, because remember, Chinese gets translated into English, or they don't know what to call it in the English language, and they can come up with some pretty weird names for tools. It was Dino that actually told me the name one time, what you can find these under. It's called de-stuffing, like stuffing a turkey, except it's de-stuffing, all one word. So just go to eBay, search de-stuffing tool, and you'll be able to find these little guys. I suggest pick up a couple of them, because these are mainly designed to be used with walkie-talkies. So Kenwoods, Baofangs, you name the walkie-talkie. That's what these are really designed for. But the holes fit other type products, much like the nut that's on here. It's a 2-pin spanner nut, but the pins are too wide. So I have several of these. One of them is kept stock for working on walkie-talkies, and then I have other ones like this where I have actually filed down to narrow the pins on these things, because the way they come, sometimes the pins are a little bit too fat to fit in the slots on the nut. So, pick yourself up 2 or 3 of these things. Trust me, it makes life so much easier to have the proper tool to remove those nuts than trying to do it with a pair of needle nose pliers or a screwdriver and a hammer. I've seen sockets and controls mangled by people trying to remove those nuts the incorrect way. But once you have that nut off, you can't get the board back far enough, or actually forward far enough, to lift it up past this flange. Now luckily this thing was designed to be serviced. So if you look down here on the side, there's 2 Phillips screws. Once you loosen the 2 screws on each side, you can actually slide. You see this just slides on that right there. It's a pivot. It's actually meant so you can fold the faceplate down. In this case, we want to move the faceplate forward so you can slide the board forward far enough to get it up, to get all of those jacks up past this flange. And then of course, like I say, just disconnect the couple connectors you'll have to remove to be able to get it up from the back. There's what, 3 or 4? 1, 2, 3. There's 4 wiring connectors, and then there's 1, 2, and then the third one's back here, the TMP connectors. And as I always say, whatever you do, do not ever remove these cables by pulling on the wire. I have had to replace so many of these things because people grab these by the cable and pull it out, and it rips the cable right out of the plug. Take a pair of needle nose pliers and grab it by that little flange. From the side, from the back, whatever, but grab it. That's usually actually how I'll grab it, like that, because it's got an ear and it's locked. Those little ears are perfect for grabbing with serrated jaws. But pull it from the connector, not from the cable, unless you really want to replace your cable. If you like replacing cables, just rip the cord out and have at it. But so I've got the board pulled up here. If I ever get this camera spun around enough, I don't know. It's running into its own boom. But let's see, right there, where are we at in the picture? Those are the pins for the ceramic filter. They look fine. There's no bad solder connections there. So I'll go ahead and get that desoldered, stick a new ceramic filter in there, get the board stuck back in, we'll fire it up and see how it works. Now I'm going to assume that the reception even though it has returned, I still think it's a little bit too low. Now, I have not aligned the receiver circuitry or anything, and actually I don't think the customer actually even asked for an alignment. No. But I will check the receiver alignment, just the sensitivity adjustments, so, you know, the stages where they're coupled together, the tunable transformers. I'll make sure that they are peaked, but I get the feeling that ceramic filter, even though by me tapping it, it's starting to work again, it's still slightly attenuating the signal. So when we stick a new one in there, I'm expecting the receive to pick up even more. So anyhow, let me get that stuck in there and we'll see how this thing works. And I won't align anything. I won't do any of those adjustments until I check it first. So we'll see how just replacing that filter, how that affects it. Okay, so we're listening to 78 or 7.85 megahertz right now, which is CHU Canada, Coordinated Universal Time. On AM, I have the RF amp turned on, attenuator turned off, and if you'll notice, the notch is turned off. There, it's turned on, just through its range. Turn it off, turn the RF amp off. You can see, of course, we have a lot of attenuation when we turn the first RF amp off. And then if we turn the attenuator on, again, also greatly attenuates the incoming signal. So, receiver is back to working like it should be. Another thing I've done is I turned the AM carrier way down on this thing. If you remember when we first started with this, it was putting out like 100 watts or more, I think, on AM. These radios are rated for basically 100 watts in every mode except for AM. It's supposed to be maximum 25 watt carrier on AM. And that varies across the bands, especially once you get up into the 10 meter band. Once you cross over into 28 megahertz, you know, the higher frequencies in these, the output power can tend to drop down a little bit. And that's all in the owner's manual and in the service manual, they tell you that. But yet, a 100 watt AM carrier on one of these things would be good for one thing: letting out the magic smoke. So that has been turned down to 25 watts where it should be. Now the filter, obviously I've replaced that now. Got the board all reinstalled in here. I re-peaked the receiver circuit right here. The main thing is when you install a component basically anywhere in an RF circuit, at the very least you're going to want to tune, and it depends, doesn't specifically apply to this radio, pretty much any radio, but if it's a tunable coil or tunable transformer, or it could even be a variable capacitor depending on what you're working on, but you want to tune the input and the output of whatever device you replaced. So if you replaced a transistor, an FET, in this case a ceramic filter, you're going to want to, at a bare minimum, retune the input and output sides of that, because that could affect the new part that you've installed, could affect, you know, could have slightly different tolerance or characteristics than the original part that was in there, because remember, no two things are exactly alike. But like I say, I retuned the receiver circuit right here, and just in case you're curious what's actually inside of one of these little things, I've actually taken this one apart. So this is the one that was in the radio. I just sheared the sides with a pair of snips, pried out the insides, and then get it all in my hand here. Here's everything that's inside of one. So there's a couple little discs here that kind of fall out. This one is flat, that has the hole in it, but this one is actually kind of bent. It may not show up very well on camera, but it's got a little bit of a bow to it, and it basically acts like a spring. And then inside here, and this is why they can fail. Now, I've seen these things where they've turned green. The metal parts in here actually oxidize or corrode. That does not appear to be what happened in this one. It's if I had to take a guess, I'd say that it has lost some of its spring tension, because there is no soldered electrical connection, basically, you know, a solid wire connection, you could say, from the input to the output of one of these. It actually goes through these little ceramic discs. Okay, there's 3 big ones in here. If I completely dismantle this thing, and there's what, 2 or 3 little small thin ones in here as well. Get all these parts pulled out. I think I got everything there, and then there's actually a couple little Teflon discs in there, and that's actually what makes up that filter right there. So you've got, there's a Teflon disc, yeah, and there's another one hiding inside that little metal spring plate. But you can see they have little contact buttons on either side, and those are meant to come in contact then with these 6 ceramic discs. So there's 6 of them that are kind of thick, okay, or 3 of them, and then there's 3 of them that are thin, okay. But what I think what really happens, the downfall of these things, is some of these over time, like I say, they lose their tension, because that's all it is. It's just pressure pushing against these contact points. And that's why when I reached in with a pointer and tapped the thing, receive popped back, because probably what it did was it shifted one of these ceramic discs in there. It moved a little bit. There may have been a slight bit of oxidation or tarnish on one of these little plates on the either side, or on these contact buttons, or any of these other plates that are in here, because that's the thing, there's a lot of contact surfaces in here where you're getting connections between these different pieces of the filter. You get a bad or slightly oxidized or dirty contact in there, your signal can't get through. You tap the thing, the part moves, starts making contact, but of course a week later it could just happen again. So that's why we replace them. And like I say, you can also, these things, it's old, it's metal can fatigue. Like I say, it starts to lose its tension if it's not holding the correct amount of pressure on this whole package holding it together. Again, it loses contact. So that's been replaced. Receives works fine now. Like I say, I've turned down the AM carrier on this thing, and the only other thing the customer wanted done was, and I did a video on that, so I didn't even bother showing it. I did pull the RF half off, the other half of the radio off here, took the cover off of the PA unit, cleaned off the heatsink compound off of the driver and final transistors, specifically the one that has the thermocouple on it. Now I just go ahead and do all 4 while I'm in there, because over the decades, because remember, this is a vintage radio, it's not an antique, but it is vintage, this thing's got a few decades on it, that heat transfer grease starts to dry out, and the bias diodes that are strapped across all those transistors aren't getting good heat off of the transistors. So basically they can't properly sense the heat coming off of them as the heatsink compound dries out. Worse yet, one of the final transistors has a thermocouple that's actually trapped underneath one of the diodes. So it can sense the temperature of the final transistor, and then once the temperature gets up high enough, that's what turns your cooling fan on, because the cooling fans are not continuous in these. They only turn on when they're needed. And again, as that heat transfer grease dries out, heat is not properly being transferred into that temperature sensor, and you can start to have fan problems. So the unit will run hotter than it's actually supposed to be before the fan turns on. So to prevent from ever having to do that again, I clean off all of that heatsink compound, the grease style heatsink compound, and then use a thermal adhesive or glue. It's what you use to actually glue heat sinks onto ICs. I put that on there. Now I never have to worry about it. It's glued on there for life. Now, yes, some people say, "Oh my God, you glued it. If you ever have to replace a part?" It's easy to get off. It's much like potting silicone. If you're familiar with how the consistency of potting silicone, it just crumbles. It's very easy to get in there and scrape off. It's not like RTV silicone, which just stretchy and rubbery. This stuff's kind of crumbly. You just scrape at it, and once it's dried and cured, you can break it off and get it out fairly easily. It does have a little bit of elasticity to it, so it does have give, so it's not like it's going to break on its own and disintegrate on its own, but it is easy to remove. The main thing is it's more reliable in the long term, so you'll never have to worry about that again with the radio. So really the only thing I got now to do is just stick the top, or actually bottom cover back on this thing, and I'll be able to box this up and send it back to the customer. Doing 75 watts less on AM. Yeah, I don't know what, maybe the last person that worked on this, I just got to look at this note again. Yeah, also, please set the output to about 120 plus watts on AM carrier. Wow. And here's the part that just doesn't make any sense. It makes the drive control adjustment much smoother. I don't get it. Having more power out is going to make the drive control more sensitive, because a tiny bit of movement is going to change wattage more. Whereas it's set now at 25 watts, when you key the microphone or push the MOX button on the front, the carrier can only now be turned up to 25 watts on AM with the drive control, so it's much more sensitive and much more easy to adjust. And you can't accidentally overpower the radio, which is, with it being set like it was before at 20 or at 100 watts, you had a great chance of damaging the PA stage in this thing. Much less if we had cranked it up to 120 plus watts, it would have been you'd have even had more of a chance of doing that. And I know some people say, oh, well, that'll never happen. Trust me, I've seen plenty of people blow up radios and blow up amplifiers because they did just this. They turned something up the whole way and forgot, especially if they were in another mode. They were in a different mode, they had the power adjusted for that. They switch modes into AM. The drive control still still cranked up to a higher level. They start talking, not looking at the power meter, and all of a sudden, what's that smell? And then all of a sudden, that's when they see the smoke coming out. So, you adjust your radios as the manufacturer designed, and they will live a very long and happy life. So, yep, nothing too serious in this. Ceramic filter. Like I say, a little bit of thermal adhesive. The customer had mentioned, I'll go ahead and point it out actually, about the light bulb. Someone had told him that it might be the 8-volt 100 milliamp lamp fuse. If it had been that, this wouldn't have had receive basically on, if you're having problems with circuits like that, a lot of times you'll have either no receive on all bands or all modes, or depending on the radio, we're talking, not specifically to this radio, but ESD protection circuits, when you have a fault there, so you had a big ESD event come in through your antenna cable into the radio. Depending what type of circuit they have, when they do their business, what they're supposed to do, if a part fails there, it can either basically disconnect the antenna from the receiver, or it could be a short. So in the case of these radios, they have a light bulb that they use, probably because they're cheaper than a glass discharge tube, or even better yet, a proper TVS diode. They just use a light bulb. So that's the little light bulb that he was talking about, and there's nothing wrong with the little light bulb there. And if you ever suspect something like that, just check it with an ohm meter. Turn the radio off. You want to make sure there's no voltage in the circuit, and just check from terminal to terminal to see if the light bulb, if you have resistance there or not, because sometimes it can actually be hard to tell if the filament's broken inside of a light bulb, even under magnification. I've seen bulbs where the contact is broken off, but it's still barely touching these elements where the wires come in. Visually you can't see it, but if you check it with an ohm meter, it's actually bad. So in any case, let me get this thing put back together here, and of course you can see I've got this cable now over this way, so it's not getting pinched in between this heatsink and the cover anymore, because we don't want to smash because that's the TX cable that goes out to the PA unit on the other side, so definitely don't want to be flattening that one out. So there you go. There's the repair of a Yaesu FT-757GX II.